Good afternoon, everyone. Let us start. Remember, we have been learning Chapter 7, Mineral and Energy Resources. Yesterday, we discussed about non-conventional sources of energy. Okay, about distribution of coal, petroleum, natural gas, and today we shall discuss about non-conventional sources of energy. Now let me present my screen. Non-conventional energy sources. It is page number 80 of your NCERT textbook, India, People and Economy. Now let us read. Fossil fuel sources such as coal, petroleum, natural gas and nuclear energy use exhaustible raw materials. Coal, petroleum, natural gas, then nuclear energy, okay, like uranium, thorium, these are exhaustible raw materials, will be diminished, okay, after uses. Sustainable energy resources are only the renewable energy sources like solar, wind, hydro, geothermal and biomass. Okay, sustainable means that is will remain sustained, okay, say without compromising the environment. These energy resources are renewable resources. Sustainable energy resources are renewable resources like solar, then wind, then hydro, geothermal and biomass. And these energy sources are more equitably distributed and environment friendly. In case of conventional energy sources like coal, petroleum, natural gas, okay, say these are localized, found only in particular places, whereas these conventional energy sources like solar, okay, then wind and then others, okay, are equitably distributed on the surface of the earth and environment friendly, does not cause pollution. And the non-conventional energy sources will provide more sustained, eco-friendly, than cheaper energy after the initial cost is taken care of. So all these lines tells the advantages, okay, or the importance of these non-conventional energy sources. Merits, okay, merits or advantages of non-conventional energy sources. So the first important non-conventional sources of energy is the nuclear energy resources, okay, and nuclear energy has emerged as a viable source in recent times, okay. Important minerals used for the generation of nuclear energy are uranium and thorium. Okay, these are the two important minerals used, okay, for generation of the nuclear energy. Now let us have a quick look at how nuclear energy is generated. Okay, let me show you a diagram. And so here, see, Here see, this is a model of nuclear power plant, and on the left side you are seeing a nuclear reactor. Okay, so here in this reactor we have to put these either uranium, thorium, okay, or other these atomic minerals, and due to the fission reaction, heat is released. Okay, and that heat is used to boil water, okay, here in the cylinder. Then from here steam is released with great force, and here turbine is rotated, and it is connected with generator, and the electricity is produced. And after that water may be cooled down and may be back. Okay, so this is about a nuclear power plant. And here in the reactor we use this uranium, thorium as a fuel. Okay, and due to fission reaction, this heat is released. So this is how nuclear energy is harnessed, and we mainly use uranium and thorium in the nuclear power plants. And now let us learn about distribution of these mineral resources. Uranium deposits occur in the Dharwar rocks, okay, in the Dharwar system of rocks. Geographically, uranium ore are known to occur in several locations along the Singhbum copper belt. Then uranium is also found in Udaipur, Alwar, and Junjunu districts of Rajasthan. Then Durg district of Chhattisgarh, Bandra district of Maharashtra, then Kulu district of Himachal Pradesh. So these are the areas where uranium is occurred. And about thorium, thorium is mainly obtained from the monazite and ilmenite in the beach sands along the coast of Kerala and Tamil Nadu. Thorium is mainly obtained from the monazite and the ilmenite in the beach sands along the coast of Kerala and Tamil Nadu. And walls recessed monazite deposits occur in Palakkad and Kollam districts of Kerala, and near Visakhapatnam in Andhra Pradesh, and one more Mahanadi River Delta in Odisha. So in these areas this thorium is found. And then this Atomic Energy Commission was established in 1948. Progress could be made only after the establishment of the Atomic Energy Institute at Trombay in 1954, which was renamed as Bhabha Atomic Research Center in 1967. Okay, that this institute, Atomic Energy Institute at Trombay, okay, was renamed as Bhabha Atomic Research Center in 1967, and only after that this India has got a progress in the field of this harnessing nuclear energy resources. And in India, important nuclear power projects are these Tarapur in Maharashtra, then Rawatbhatta near Kota in Rajasthan, Kalpakam in Tamil Nadu, Narora in Uttar Pradesh, Kaiga in Karnataka, and Kakrapara in Gujarat. Okay, so these are the important nuclear power plants in India. In our book, you will not find a location of these nuclear power plants, but it is important for the these map items in the CPC exams. And here I have, okay, a map here. Actually this map has been taken out from the class 10 book, okay, class 10 geography book. And here you will see the locations of the important these nuclear power plants. You have to see the red triangles. Here we have Naraura, and okay, so this is Rawatbhatta in this Rajasthan. Then we have Kakrapara, then we have Tarapur, okay, then Kaiga, then Kalpakam. So these are the important nuclear power plants in India. Okay, I may upload this map in the WhatsApp group. Now any question regarding these nuclear power plants, boys and girls? Any question regarding nuclear power plants? Okay, then let us proceed. Next, non-conventional energy resources is solar energy, and it is ubiquitous, found everywhere. And how solar energy is harnessed is given here. Sun's rays tapped in photovoltaic cells can be converted into energy, and known as solar energy. And two effective processes considered to be very effective to tap solar energy are photovoltaics and solar thermal technology. Okay, so we have two important processes to harness solar energy. The first one is the photovoltaic cells. So this is very common here. Okay, so we are using solar panels, and in the solar panels you may find many these photovoltaic cells. See here, so this is a solar panel. See this diagram, and here in the panel you will find photovoltaic cells, and these photovoltaic cells directly convert the sunlight into energy. Okay, and here again the energy is converted to electricity, and it may be stored. Okay, it may be stored in this battery, or can be used directly. Okay, so this is how this sunlight is harnessed using these photovoltaic cells. And another one is this solar thermal technology. Okay, solar thermal technology. So in this case, say mirrors are used. Okay, so in this case, here this is an example. Okay, there are so many ways of harnessing this sunlight, solar energy, but this is one of the methods. Okay, see here, these are these mirrors. Okay, so these are the parabolic throw, these are mirrors, and see, I will show you a photograph. Okay, see, so here we have to display all these mirrors here in this way. And let us have a close-up. Okay, so here this is a mirror, and here I think you are seeing a pipe. Okay, steel pipe, and here inside the pipe this liquid is flowing, and the sun's rays are focused on this pipe, and because of that the water in the pipe is boiled. Okay, see here, the sun's rays are focused along these pipes. Okay, filling with liquid or water, and it is boiled, and here it turns into steam, and the steam is used. Okay, the steam is used to rotate the turbine, which is connected to generator, and in this way electricity is harnessed. The same liquid can be again recycled. Okay, can be recycled in this way. So this is one of the methods of this harnessing sunlight using solar thermal technology. Okay, using solar thermal technology. And this solar thermal technology has some advantages all over all other non-renewable energy sources. it is cost competitive. Okay, after installation, this repairing and other maintenance costs may not be there. It is environment friendly, no pollution. It is easy to construct. Okay, and one more advantage is that solar energy is 7% more effective than coal or oil-based plants, and 10% more effective than the nuclear plants. And it is generally used, okay, more in appliances like heaters, crop dryers, cookers. Okay, so these are the these merits and the uses of solar energy. Okay, and after that we have to memorize the potential areas. Okay, the western part of India has greater potential for the development of solar energy in Gujarat and Rajasthan. Okay, say Gujarat and Rajasthan area, so these are dry areas and suitable for development of these solar power plants. Okay, development of this or harnessing this solar energy. So these are the potential areas, western part of India, especially in Gujarat and Rajasthan. Okay, so any other question about this solar energy, boys and girls? Any question regarding? Okay, let us proceed. Next we have this wind energy. Okay, so wind energy is absolutely pollution free, inexhaustible, means renewable source of energy, and the mechanism of energy conversion from blowing wind is simple. Kinetic energy of wind through turbine is converted into this electrical energy. I think you have also already seen about it in the televisions also. And here, see, here you are seeing windmills. Okay, a series of windmills, and here turbine is rotating when the wind blows, and the turbine is connected with the generator here on the back, and in this way this electricity is produced. Okay, in this way wind energy is harnessed. So this is about this wind energy. Okay, harnessing wind energy. And the permanent wind system, that is a planetary wind system, okay, such as trade wind, then westerlies, then seasonal wind like monsoon, have been used as a source of energy. And beside these, local winds like land and sea breezes, that is near the coastal areas, okay, can also be used to produce electricity using the windmills. And about the areas, okay, potential areas and developed areas, India already has started generating wind energy. In Rajasthan, Gujarat, Maharashtra and Karnataka, favorable conditions for wind energy exist and started developing. Okay, in Tamil Nadu also we have these windmills harnessing this energy. And next we have this tidal and wave energy. Okay, tidal and wave energy. See, ocean currents are storehouse of infinite energy. Since the beginning of 17th and 19th century, persistent efforts were made to create more efficient energy system from the ceaseless tidal waves and ocean currents. So how these tides are used for harnessing energy? Okay, so let me explain you in a very simple way. And say here let us say this side is sea. Okay, and so this is the sea level, and here. So we have to make a reservoir or a tidal basin. We call it a tidal basin. And when the sea level rises, okay, due to the this gravity of the sun and the moon, the sea level may rise up to here. Okay, that is known as high tide, and the water may overflow here, or there may be a floodgate here, and see, through this hole the water may be entering here and just filling up the tidal basin. And here at the bottom there may be, okay, a tunnel, another tunnel here. And if we keep a turbine here, then it is rotated when it is in the this low tide position. Okay, and say water will be released with a great force, and turbine will be rotated, and electricity is produced. Or so on the other side also, see here, we may make another floodgate here, and we may keep a turbine here and connecting to a generator. Okay, this here we have the turbine, and the water is okay, released with a great force, turbine is rotated, electricity is produced. Okay, so this water may be used in irrigating certain crops like coconut and other some varieties of paddy. Okay, so this is one of the ways of this harnessing tidal energy. And here also some diagram also here. See, this I have already drawn. Okay, see, high tide, water is coming here, this is the tidal basin, and here we have the turbine, and in the low tide condition water is released, and here power is generated. Okay, so this is how tides are used for generating electricity. And about the webs, okay, about the webs, how these webs are used. See here, webs, you know, I think all of you are familiar with the webs. And see here, when we have to make a structure like this, and when the web water is rising upwards, here okay, will be forced towards it, and this turbine will be rotated, and the electricity is produced. So just watch a video. Okay,
the water of the oceans of the world is almost always in motion. Hardly ever interrupted, waves break at the coastlines, sometimes strong, sometimes weaker. There is an enormous energy potential that is available round the clock and free of charge. A potential that, if fully exploited, could satisfy 40% of the worldwide demand for power. This equals the output of 700 to 800 nuclear power stations. Voigt Hydro Wavegen is developing technologies to convert this inexhaustible energy into electric power without the emission of harmful greenhouse gases. The operating principle of this wave power station is as simple as it is ingenious. An enclosed chamber has an opening beneath sea level, which allows water to flow from the sea to the chamber and back. The water level in the chamber rises and falls with the rhythm of the waves, and air is forced forwards and backwards through the turbine, connected to an upper opening in the chamber. As it is compressed and decompressed, the airflow has sufficient power to drive the Wells turbine. It is a feature of the Wells turbine, named after its inventor, that it is driven in the same direction by both forward and reverse airflow through the turbine. Even relatively low wave motions can generate enough airflow to keep the turbine moving and to generate energy.
so in this way, waves, okay, ocean waves are used for harnessing energy to produce electricity. And now let us read these potential areas. So large tidal waves are known to occur along the west coast of India. Okay, so this is the potential area, and hence India has a great potential for the development of tidal energy along the coast, but so far these have not yet been utilized. Okay, we have the potential but not utilized. So before we continue for geothermal energy, do you have questions, boys and girls? Do you have any question regarding this tidal and wave energy? Okay, then let us proceed. Next we have geothermal energy. Okay, when the magma from the interior of the earth comes out on the surface, tremendous heat is released, and this heat energy can be successfully tapped and converted into electrical energy. Okay, see here there are different ways of this harnessing this geothermal energy. Okay, different ways are there harnessing this geothermal energy. See here, so we have different ways. Okay, sorry, this is about not about this geothermal. So let me explain. Okay, actually here in the volcanic area, especially this Iceland, for example, Iceland, actually there are so many active volcanoes, and here geothermal energy is very rich. And how energy can be tapped, okay, say I will explain. And see here, this is the surface, okay, the crust, and here we have this mantle, and here we find these pools of magma. Okay, magma is here, and here in the volcanic areas, okay, there are so many holes, and the small holes and the cracks are here, and through these holes and the cracks, these very hot steam are coming out on the surface. Okay, in the volcanic areas. And one of the method of this harnessing the geothermal energy is this collecting these steams using pipes. Okay, so from these whole steams, very hot steams may be collected using steel pipes. Okay, and from here also can be collected using steam pipes, and from here also it may be collected using steam these steel pipes. And these at the end we may keep a turbine here. Okay, we may keep a turbine here, and say when the steam hits the turbine, then it will be rotated, and the generator will produce electricity. Okay, so this is one of the methods. So in the other case, what we have to do is all these pipes, okay, may be joined to a big cylinder. Okay, to a big cylinder containing a liquid, okay, which can be boiled at a low this heat also, or it may be filled up with water. And so because of the steam, the water here may be boiled, and here at the terminal steam may be released with a great force. And here if we rotate a turbine connecting to a generator, then electricity is produced. So in this way geothermal energy is harnessed. Okay, you know geothermal means the energy, okay, obtained from the earth's interior. The heat energy obtained from the earth's interior is known as geothermal energy. And apart from this, the hot water that gushes out through the geyser wells is also used in the generation of thermal energy. Okay, so apart from collecting these steams in the volcanic areas, hot water springs and geysers, okay, are also used in generating this thermal energy. The process is the same. So what is geyser? Say you might have learned in class 11, but let me show you a photograph of geyser. Okay, see, so this is a photograph of geyser. Actually here very hot steams are ejecting. Okay, very hot steams are ejecting at the interval of 10 to 15 minutes. This is very hot one, and with a great force. And here this hot steam may be captured using pipes, and it can be used in generating electricity. Okay, so this is another way. Do you have any question regarding this? Okay, Tongo, how it may be due to this poor internet connection. Okay, so I will try to speak slowly. And now this geothermal energy is considered to be one of the key energy sources. Okay, and eco-friendly also. And in case of India, a geothermal energy plant has been commissioned at Manikaran in Himachal Pradesh. A geothermal energy plant has been established at Manikaran in Himachal Pradesh. Okay, this is about geothermal energy. Geothermal energy means the heat energy obtained from the earth interior. Okay, it can be used in heating the rooms, or can be used in generating electricity. And the last this non-conventional source of energy is bioenergy. Okay, so bioenergy refers to energy derived from biological products. Okay, energy derived from biological products which include agricultural residues, municipal, industrial, and other waste materials. I think you might have learned about bioplants. Okay, say in science classes you might have learned about biogas plants. And here this is a cross section. Okay, see here, say here in this section we are throwing this cattle dung water as a slurry, and we can also throw these agricultural residues, municipal waste materials. Okay, here in this tank there will be decomposition. Okay, and this highly inflammable gas is produced, and that is known as biogas. Okay, here a pipe is connected, and it can be used directly or can be used in harnessing electricity, also in generating electricity also. See here, bioenergy is a potential source energy conversion. It can be converted into electrical energy. How? Bioenergy can be converted into electrical energy. It is very simple. Okay, say simply we may use this bioenergy as a fuel in the thermal power plant. Okay, we may use this bioenergy biogas in a thermal power plant. Here, see this diagram. See here we have this container. Okay, a cylinder filling with water, and here we have to say burn. Okay, using this biogas. Okay, at the furnace we may be using biogas to boil the water. Then steam is released this with high pressure. Okay, then here turbine is rotated, connected with the generator, and the electricity is produced. So in this way biogas can be used, okay, to generate this electricity. And heat energy for gas and cooking. So biogas is also used for cooking, and so it can be produced, okay, say using waste and garbages. And say using bioenergy will improve this rural life. Okay, will improve the life of rural areas in developing countries, reduce environmental pollution, enhance self-reliance, and reduce pressure on the fuel wood. So it has so many advantages, it has so many merits. Okay, if we use bioenergy, then it will improve the economic life of rural areas. So we may use these agricultural residues, vegetable waste, okay, then domestic wastes, and that can be used in cooking. And again that the residues, okay, in the biogas plant may be used as a manure Okay, so we have got the dual purpose of getting energy as well as getting manure for the agricultural fields. And bioenergy is also environment friendly. Okay, and it will reduce pressure on the cutting of wood. Okay, pressure on the fuel wood. And one such bioenergy plant project converting municipal waste into energy is at Okhla in Delhi. Okay, this is an example of bioenergy plant. And last we have this conservation of mineral and energy resources. So here in these lines you will find why conservation of mineral and energy resources are important, necessary. So let us read. Traditional methods of resource use result into generating enormous quantity of waste as well as create other environmental problems. So use of conventional sources of energy like coal, petroleum, natural gas, okay, and others result in the enormous quantity of waste as well as these causing environmental pollution. Hence, for sustainable development calls for protection of resources for future generation. We have to reserve for our future generations. Okay, and there is an urgent need to conserve the resources. So to have a sustainable development, we need to conserve the mineral and energy resources, because most of the mineral and energy resources are exhaustible, cannot be renewed. Okay, and that is why we need conservation and management of the mineral and energy resources. Then how the mineral and energy resources can be conserved is given here. Okay, the alternative energy sources like solar power, wind, wave, geothermal energy are inexhaustible resources, so we have to use it. Okay, alternative energy sources like solar, wind, wave, geothermal energy are inexhaustible, that is renewable, and they should be developed to replace the exhaustible resources. We have to use non-conventional energy resources, okay, to replace the conventional one. In case of metallic minerals, okay, this use of scrap metals will enable recycling of metals. That means we have to recycle the scrap metals. We have to collect scrap metals from the household and it is to be recycled. Then use of scrap metal is especially significant in metals like copper, lead, zinc, okay, in which India's reserves are very meager. So India's reserve of copper very small, okay, then lead also, then zinc also, and that is why recycling of these metals is very, very important for a country like India. Then use of substitute for scarce metals may also be reduced consumption. So this is another method of conserving our resources, that is substitution. So whenever possible we may substitute, replace the use of metals. Say for example, we may replace the use of these iron pipes, steel pipes by polythene pipes, example, okay. And the export of strategic and scarce minerals must be reduced so that existing reserve may be used for longer period. Means legal provision must be there, okay, to control, to check the export of strategic and scarce mineral. That means scarce mineral, then strategic, very important minerals should not be exported on large scale. It may be preserved for our future generation. So in this way, minerals and energy resources can be conserved. Okay, so any question from your side? Tongo, how which diagram you want to explain? Tongo, how? I did not see your message. Okay, geothermal energy. Okay, I will explain. Okay, I think about one more diagram is there. See here. See, this is another method. Okay, Tongo, how? This is another method. See here, inside the earth temperature is very high. Okay, especially in the volcano areas, in the earth interior temperature is very high, and that is why see from the underground very hot steam. Okay, hot water may be collected using steel pipe, and this hot water is used to rotate. Here it is collected here, and from here it is ejected with a great force, and here turbine is rotated, connected with the generator, and the electricity is produced. And the same water, after rotating the turbine can be injected, in the underground again. So this is another method, that which I did not explain. In my case, actually see, so in this case here actually especially in the volcanic countries, in the countries where so many volcanoes are there, hot steams are released through the cracks and the holes. So here there may be lots of cracks in the volcanic areas like Iceland. Iceland is the best example, and here in Iceland geothermal energy is very rich, and through these cracks very hot steams. See here, if we have a layer of water aquifer, and if this aquifer is connected with a magma chamber, for example this is magma, and if magma is happen to rise, then the magma, when the magma contacts with the water, it will turn into steam within few seconds, because the temperature of magma is more than 1000 degrees Celsius. And when the water is contacted by magma, the water may be turned into steam, and this steam may be ejected on the surface with great force. And this very hot steam may be collected using pipes, using pipes. And here if we keep a turbine here, then electricity can be generated. This is one of the methods, in which the hot steam is directly used to rotate the turbine. In the other case, just like the thermal power plant, just like the thermal power plant, we have to collect all these hot steam from every hole, from here. Then again, here we have a cylinder filling with water, and the hot steam will be used to boil the water here, and at the end of the cylinder the boiled water will release steams, and here if we rotate the turbine, then this electricity is produced. So this is another way of this harnessing this geothermal energy, and this is one of the ways. So many ways are there. 4 or 5 methods are there for harnessing this geothermal energy. Simply we have to collect, we have to tap the heat from the earth interior. The hot steams, the hot water from the earth interior must be tapped using pipes. If it is hot enough, then it will turn into steam, and the steam will release at the terminal of the pipe, and a turbine can be rotated, connecting to generator, and the electricity is produced. Any other question? Then let us stop here for today. Please leave your name in the WhatsApp group for attendance. Thank you very much for joining my class.